right, guys. John, if you can just turn off the music, then you can start now.
Cool. Yeah.
Okay, everyone. Thank you for being here, and thank you guys for joining from different part of the world. Magda is joining us from Europe. Later, you'll introduce yourself and where you're coming from exactly, because I really have limited information. And the rest, I think the most of us are based in China. Somebody's struggling with lockdown here in Shanghai. Somebody's, like having a very, very nice life also. Now, what I will do first, on behalf of Unpack AI, I would like to say a few words about, the platform, what we've been doing, and then I'll pass, like the mic to our speakers. Okay. So our mission, guys, in Unpack AI, to make AI relevant to business professionals, to industry experts, to entrepreneurs, so then they can understand what is AI and apply AI back in their industry, in their company, to have impact for their career, for their life. Okay, that's the main goal. Of course, in contrary to self-studying, we utilize the community spirit. We have cohort-based learning programs, and that's the core of what we do in Unpack AI. We help non-coders, learners to dive very quickly with AI and then build a network along with that, right? And we have tons of the community events, speaker sessions, webinars, the one that you join for, right? We have online groups. Our students also write the Medium publications, again, to increase their online presence and so on. And of course, like we love to do offline events, but due to lockdown, it's just very hard for us to carry out. And of course, in the core of our company is the AI learning program, which is like give really good dive into the AI with the four areas that we cover in our course, which is computer vision, predictive analytics is where you work with spreadsheet data, recommender systems, again, the backend, which is behind Netflix, Taobao, on giving targeted recommendation to the products that you buy, right? Natural language processing. And you'll guys see these areas are rely on data. And again, like it's very exciting how we will connect our training program with what the speakers will talk about, because this so-called supervised machine learning. So you have to tell machine on where is the data, how to look at the data, and what you want machine to predict based on the information, again, in the data, the patterns that software AI has to recognize. And another good part of our community as the whole is the transition of our students to the graduates, and then if they advance to more technical course, they can get back as the mentors and teach more and more students, because again, our students are the experts in their own field. They're very good working with people, and they now have a very deep understanding of how they can apply AI, and their even language, the way they teach is more applicable and useful for, again, non-coders, business professionals. In contrary, for example, to the machine learning engineers who can be too technical, easily dive into the coding, into some technical aspects. For example, our mentors are able to onboard, like more and more students, more and more professionals easily. And again, thanks to our learning program, to our guidelines, they really succeed in that. For example, this is the work one of our students. He's a medical professional from India, so he built an image classifier that can, for example, distinguish between brain tumors, right, using MRI. And again, like he can achieve top industry accuracy, again, like with the code pipeline that we provide to him within our learning program. And of course, like our training program is certified. You can share on your LinkedIn. Again, we help to endorse the skills. We help everyone to excel in the career after finishing the training program. And yeah, if you're interested, you can reach me out. But again, I'll probably mention again a few words about the training program after the webinar. But right now, guys, let me stop sharing the screen. Let me now introduce you our webinar. So our webinar is focused around the technologies that are utilized to power data-centric AI. So in the core, of course, the data. If we look, into the how AI is built, it's all around data, right? You will hear a lot about the words like training data sets, for example, humans in the loop. So without people actually doing the data annotation, data labeling, you're not able to have, for example, the data as the food, as the input to build the AI models that then you can scale up in the production. But I'm not going to explain all this stuff because we have much knowledgeable experts who will be, again, explaining everything. And I also hope for the speakers, if you guys will try to stay as high level as possible and slowly onboard people into the technical aspects, business challenges, etc. So, they will be relevant to what you're talking. And now, according to the structure, I would like to invite first Sara, who is running her data labeling boutique company and helping the companies that are dealing with text data, with NLP data to build, again, AI models in this area. And after that, I will call on Magdalena, who is joining us from Europe, on how big company Toloka could scale up data labeling into the platform and what it does and how it helps the big companies, AI companies, to build AI models, AI products as quick as possible, and how, for example, humans in the loop, help again to improve the models over the time, or not let the models at least to degrade, right? Because there is another also issues in after when you deploy the machine learning models. And then I would like to call on Leo, who will be talking how now Web3 blockchain steps in and again accelerates AI innovation. So thank you guys for joining. And please, Sara, if you can start with yourself, introduce yourself, and then dive into the topic. For each of the speaker, we give 20 minutes. After that, we will have Q&A at the end after each speaker presented. We'll have some Q&A, and then we'll more have a discussion for everyone. Thank you so much again. Sara, please, your turn if you can unmute yourself, and let me make sure that you guys are able to share the screen. Here we go.
Great. Thank you so much for having me. Let me just share my screen. Okay, you should all be able to see that now and can hear me okay, I think. Yeah, thank you so much for having me, Unpack AI. So I actually recently took the DL 101 course with Unpack AI, which was a course that was focused on giving non-coders the skills to understand how AI works, both at the broader level, and also to give us the skills to dig in and actually play with the code ourselves, see what we could actually tailor make to our own business purposes, so as Idar has explained. And that was really useful for me because I actually come from a linguistics background. I'm trained in psycholinguistics. So that means how language works in the brain. And my skills include things like documenting grammars and testing intelligibility of dialects and so on. I actually only had a very, very basic knowledge of coding from grad school a really long time ago. So the course was really perfect for me. And I was interested in Unpack AI because in the last few years, my translation company has actually been approached more and more to provide language data services for NLP. And this has been a really big part, it's become a really big part of our product mix. And our clients are happy with the data that we're preparing, but I still felt like, since I didn't truly understand the higher level concepts of how AI worked and what happened after we handed our data over to our clients, I still couldn't really feel like I was offering my clients the most comprehensive solution. So that's how I ended up working with Unpack AI and taking their course. I completed their course last month and I'm taking the next level soon. Very excited for that. So as for today, I think that the best way that I can provide value to this audience, other than hyping up my awesome company, is to help you understand why machine learning requires the input of human linguists or language specialists to prepare their training data. So to do that, I'm going to spend 5 minutes teaching you some really basic linguistics, nothing too complicated, don't worry, then 5 minutes showing you what linguists do to contribute to language data for machine learning. And then we'll just wrap up with a few examples of the kinds of projects that linguists work on and how their data contributes to the training of machine learning models. So first I'll introduce my company a little bit more. Meridian Linguistics. We incorporated in Hong Kong in 2013, but I'm based in Beijing myself. We started as a translation company, as I mentioned, but we're now starting to offer a lot more training data for training data collection and annotation for machine learning purposes. And we also train linguists to perform these kinds of linguistic annotations. So, okay, we're going to launch into a little Linguistics 101 here. We're going to start with a quick test. It's a little English test. So if you're a native speaker or non-native speaker, I'd like to hear from anyone here. Does anyone want to volunteer and tell me which of these sentences is grammatically correct?
Is there anybody else who wants to jump in? Okay. I think we have in the chat right now the answers coming.
Yeah.
Cool.
Yeah, good. So we have a consensus already for the third, a very clear consensus. Does anyone know, and it's okay if you don't, but do you know why the third sentence is grammatically correct? I'm keeping an eye on the chat.
There's an order, there's a specific order that you have to follow. For example,
do you know what the order is?
come before the size, the noun after the adjective.
Exactly. Very good. And you're actually kind of ruining my example here because my point was going to be that we all know this rule intuitively, but we don't really know why. So most people, I don't think will know the actual reason why we have to phrase it that way. But as we heard, you have to go in the order of opinion, size, age, shape, color, origin, material, purpose, noun. It always has to go in that order. So I just think that's really crazy that we all have this intuitive, or especially native English speakers or highly fluent English speakers have this intuition that that third sentence is the correct one, but they don't, most of the time, don't even know why. They don't actually know the rules. So the reason why I fell in love with linguistics is exactly what we just witnessed there, that we all have the rules embedded somewhere in our brains and we can tell when it's violated, but we usually can't even explicitly explain why. So if you've ever tried to teach your native language, you've probably had this experience. So language is clearly more than just some kind of skill we're taught. It's more than just playing piano, or it's more than just playing chess. There's something kind of innate and mysterious to it. So that's why I really fell in love with linguistics. But it's also what makes it a really difficult problem for machine learning. So what is language? So a language is not a communication system devised by wizened academics with long beards and longer CVs. It's really important for us to understand that. What it is a communication system that arises spontaneously, standardizes instinctually, and then is documented by academics with long beards and longer CVs. So it's actually almost always the case that linguists are scrambling to keep up with the changing rules of language. It's not the other way around. It's not that linguists create language. It's that language arises spontaneously and the linguists have to scramble to keep up and figure out what those rules are. So that's a really important point for you to understand if you want to understand why language is a hard problem for machine learning. And many of you may already understand this, but I've actually found that throughout my career, most highly educated, very worldly, very intelligent people don't actually spend that much time thinking about this. And therefore, they actually still hold some pretty significant misconceptions about how language works. And that's totally understandable. I had the same misconceptions before I started studying linguistics. But the reason why this is relevant to how we work in machine learning is that if you thought that the first situation were true, which is that linguists created language, then language would be a really easy problem to fix, right? It'd be super easy. Linguists would just write out the rules and tell the computer, and then we're done. But in fact, and this never ever ceases to blow my mind, even though we all instinctively know the rules of our native languages, linguists are still scrambling to figure out how probably half of those rules work. So that means that you and I can instinctively say this sentence is wrong, this sentence is right, but linguists still might not be able to say why that sentence is wrong. So for English, linguists do know most of the basics now. We know how to conjugate verbs, we know how to pluralize, etc. But there are a lot of problems that are still really difficult to solve, and that's what linguists work on. So what do linguists study? Linguists study phonology, which is the meaningful sounds of a language. So for example, if I say the words rot and lot, these are two different words in English because R and L are meaningful sounds in English, but they're not actually two different meaningful sounds in Japanese, for example, because R and L are not two different meaningful sounds in Japanese. So phonology is the study of what's meaningful. So for example, the words pal and pal are two different words in Korean, because P and P are actually two different sounds in Korean. Although if you speak English and you don't speak Korean, you probably had trouble hearing the difference between those two sounds. So if you want speech recognizers, so we're pivoting back to machine learning here, if you want speech recognizers to understand what sounds are relevant to a language, studying phonology is really important. So linguists also study registers, they study formality. So if you're creating a Siri or an Alexa or some kind of voice assistant, should you be using the formal Korean when you're speaking to Siri? Or should Siri use the formal with you? If Siri is speaking to an 8-year-old human master, should she be using the formal or the informal? These are all really important questions for linguists to help the engineers to create their models. Dialect, so understanding what's an accent, what's a dialect, where are the intelligibility boundaries. If you're creating a car and you want the car to be able to understand voice instructions, should your car be able to recognize Dongbei accented Chinese? How about Cantonese? Does it need to understand Cantonese? Maybe your customers are just fine using Mandarin. These are the questions that linguists can help you figure out. So what do linguists do? So these are a few different things the linguists can do after they're trained in linguistics when they finish their BA or their MA or their PhD. I'm not going to go into most of these here because we're just going to focus on today how linguists work with engineers to annotate the data and to prepare the machine learning models. So these are different ways that linguists can do that. So they might work, so almost all will be in natural language processing. They might work on machine translation, so training models to create machine translation. They might work on automatic speech recognition, text-to-speech sentiment analysis, so analyzing large chunks of data to tell you, oh, the majority of these customer reviews are positive, the majority of these customer reviews are very negative. Named entity recognition, so recognizing different parts of a sentence, whether it's an organization or a person or any other kind of item that might be interesting to the client. Parts of speech tagging, so lots of different ways that linguists can contribute to machine learning. So here's a sample project that we worked on at Meridian. The client needed a robot dog, so they were creating a robot dog that already spoke German, and they wanted to enter the Swedish market. So they wanted the dog to understand Swedish. Now, of course, since this dog was tailored towards children, they wanted the dog to understand Swedish children and also the Swedish parents. So they had already a long list of German phrases that they were using with the toy dog. So we needed to first translate those phrases, then identify any new phrases that Swedes might say to dogs, because you can't always just translate a sentence and assume it's going to work in the same way. There are probably some sentences that Swedes tended to say to dogs that Germans didn't say. Then we had to get about 3,000 different people, adults and children, to record those phrases. And they had to be recorded as naturally as possible, because when you read something out loud, it sounds differently from when you say it naturally. So we actually had to design scenarios that would elicit those phrases in a natural way. So it was quite complicated. And then we had to transcribe those phrases phonetically and then provide that training data to the German technology company, who then used that data to train their model. So this was definitely one of my favorite projects that we worked on, even though it was incredibly challenging. They say in the movies, don't work with children or dogs, and I can confirm that it's very, very challenging, although the Swedish kids were very, very cute. And here's another project that was particularly fun. It's because I was working in Korea at the time. It was right before the Pyeongchang Olympics. Naver is basically Korea's Google or Baidu. And we were preparing a machine translation app that they wanted to launch by the Olympics. They already had Korean to English, but they wanted Korean to French and Korean to German. And they had a pretty impossible deadline of 3 months to collect the training data. So we put together a team of 50 translators and 10 supervising linguists to ensure a mean level of accuracy. And that was a pretty big challenge, but when we mailed over the last 10,000 words on the day of the deadline, then we celebrated big. So that's another example of the kinds of training data projects that our linguists work on. So in summary, I'll wrap up. I hope that you now have a good sense of how language works, first of all, and then why collecting and preparing the quality training data, language training data, is a little bit more complicated than you might have thought. And you also know a little bit more now about what linguists do and why they're necessary for ensuring the quality of your training data. And we also saw a few examples of what Meridian does and how linguists work together with engineers to prepare the data. So I hope that's all a little bit clearer now. So I also just want to emphasize that linguists are trained to ask the questions that you don't know necessarily to ask. So for example, do I need to include Dongbei accented Mandarin in my training data? You know, if I make this car and I want it to recognize voice activated speech, but then we get a customer that speaks Dongbei Mandarin, are they going to have a terrible user experience? Do we care that they're going to have a terrible user experience? That's something that linguists can help you with. I mean, you might not have known to ask that question if you weren't familiar with the language and if you weren't a linguist. And then finally, linguists have a variety of specializations. They might specialize in phonology, semantics, many different fields. So if you do hire a linguist to work on your machine learning project, then make sure that you're hiring one with the right background. So that's it from me. Thank you everyone so much. And I'm not sure if we have time for questions now, but you can always stick your questions in the chat and I'll answer in the chat. And you can reach out on LinkedIn if you have any other further questions after this. But yeah, that's it for me. Thanks a lot.
That's pretty cool. That's pretty cool. Definitely, we'll actually have all these questions at the end after all the speakers presented. Thank you so much again, Sara, for this amazing introduction to the linguistic problems when you actually have to build AI systems with in NLP. And yeah, guys, if you have any questions, please drop the questions in the chat box, and then we'll go through the questions and bring back to the speakers after each speaker presented. And now, without further ado, I would like to give a stage to Toloka. And as Magda suggested, let's start with Maxim, who will introduce Toloka, because now Toloka is expanding globally, and they have also operations in Asia. Maybe Maxim, you can just very, very briefly, in 1 minute, what is Toloka, what it does, and then so we can pass the mic to Magda.
Hey guys, thanks a lot. Thank you for the introduction. It's just only 1 minute short speech. So my name is Max. I'm an international growth lead in Toloka AI, and I'm responsible for international business development in Toloka. Currently, our company is orienting its business efforts to Asia and China in particular, and we are searching for AI and machine learning B2B partnerships inside mainland China and Asia at large. And first of all, I'm speaking about data labeling partnerships. Like if you need data label services or you would like to integrate data labeling inside your platform, we can try and discuss the possibilities. I will leave a link in chat to my LinkedIn profile. You can text me, and if this sounds interesting, we can discuss it. Thank you very much.
Cool. That was short and sweet. Thank you, Max. And Magda, please.
Yep. Let me share my screen. Yeah, can you see it, guys?
Yes, all good.
Thanks. So, hi everyone, and thank you Unpack AI for organizing this event. So the title of my talk today is Utilizing Crowdsourcing for Building Data-centric AI. And let me get started with introducing Toloka. Already Maxim did it, but what we do is we are a data labeling platform, and most of the data labeling we do is to power AI products. We have over 10 years of experience in the industry, and you can see some brands we've been working with. And I also wanted to show you at the beginning what kind of industries we do data labeling for. So it mostly involves search engines, voice assistants, and all of these different AI products that you can actually see here. So pretty much every kind of AI solution requires data labeling, and this is what we do. And let me just quickly tell me a bit more about myself. So I work currently as a data evangelist at Toloka. Previously, I worked for several years as a data scientist, NLP engineer, and different roles across data science industry. I've been also involved in teaching data scientists, and I publish in Medium publications such as Towards Data Science. So I heard Unpack AI students do publish there as well. So if you want, you can get connected there. And this is our agenda for today. So we're gonna start with talking about 3 pillars of AI at the beginning. Then I'm gonna tell you about a model-centric approach versus data-centric approach in machine learning. Then I will tell you a bit more about crowdsourcing and how crowdsourcing can help you with data annotation and model monitoring. So let's get started. So as I mentioned, you might actually be familiar that many AI products kind of are built on 3 main pillars, and those are hardware, algorithms, and data. And if you've been studying data science or you work in the industry already, you probably have noticed that hardware and algorithms as pillars already have really good solutions that has been provided in recent years. So for example, in hardware, we have really good computing powers that are easily available to anywhere. The same with storage. So companies such as AWS, Microsoft Azure, Google Cloud provide really good solutions there. Also, this algorithm section has been vastly investigated in recent years, and we also have really good libraries that touch on the algorithm section. So you could think about TensorFlow, PyTorch, CatBoost here. However, if you think about this 3rd pillar, data, maybe many of you, there is not much solutions that come into your mind. And this is maybe because in recent years, this pillar has been kind of neglected. But I think this is changing now. And this actually brings the problem I mentioned about model-centric AI, which is connected to the 1st pillar, and the data-centric approach that becomes popular now. So let me tell you more about this model-centric approach that has been popular in the recent years. So this is probably the most common way of building machine learning algorithms that you are familiar with. So the first step usually is to gather a lot of data. Then you work on choosing a model. So you usually try several models. It could be like a neural network, some kind of a forest, even linear regression, SVM, anything there. Then the next step, once you already chosen the algorithm, is to fine-tune parameters. And this is a painful one. Usually you can do it manually or use some kind of libraries for space search parameter tuning. But what's most important here is that in this approach, most of the time is spent on choosing and fine-tuning the model. And this is a picture that kind of could visualize this approach. Pretty much what we do, we throw some data into linear algebra, we collect answers on the other side. And well, if the answers are wrong, well, we just steer the pile again. So we fine tune the parameters, maybe we choose different model. And recently we have kind of realized that maybe this is not the best approach. And so no one really has been exploring this before, but recently we decided, but what actually if instead of focusing on tweaking the parameters and choosing the model, I would fix the most basic thing, the data itself. Basically garbage in, garbage out. So this is kind of the essence of this data-centric approach. So in this approach, we focus on improving our data. And this brings us, again, different kind of problems that we had before. So imagine you are labeling images, you ask someone to label a fox, and one person labels it as a person using a green box, and another person labels it as using the red box. So which answer is correct? So probably we cannot decide it here, but a person who designs these data labeling pipelines should know and should give clear instructions to people who do data labeling. So if we give this picture to 20 different people, you would expect them to do it in a similar manner. Definitely not something you can see it here. And what is crowdsourcing and how it can help here with this data-centric approach? So, in an essence, I would say, who should label those images? So normally in recent years, a lot of data labeling has been done in the so-called in-house, using so-called in-house approach. So basically data scientists or maybe a dedicated data labeling team would label this data. But this actually, this approach is not always the best. Usually it's very expensive, it's hard to measure, and especially hard to scale. So imagine that suddenly you need to label more data. What do you do? Do you hire more people, etc.? So another way of doing this problem is using crowdsourcing. So what is crowdsourcing? It is basically taking a big task, breaking it down to smaller components, distributing these smaller tasks for between different people, and every person would do a very small chunk of the work, and then those results are aggregated to get the final results. And data labeling can be actually done using crowdsourcing. In order to be able to use do data labeling using crowdsourcing, we need some kind of a platform where people such as requesters, data scientists, machine learning engineers, etc., here on this picture on the right-hand side, are able to post data labeling tasks. The platform should distribute those tasks in some intelligent manner to the performers. So those are people on our left-hand side. That way we could gather data using crowdsourcing. Ideally in this process, people who are involved in our crowd would be distributed in different places in the world. This is actually a picture of Toloka's crowd. You can see that people are distributed in different parts of the world. They speak different languages. They come from different cultures, etc. And this is very important when you do data labeling to avoid possible biases in your data sets, etc. Once you have an access to this multilingual, multicultural cloud, you would like your process, you would like to treat your crowd as another computing cluster. In order to achieve it, you need some kind of API. So we data scientists, machine learning engineers, we don't want to use things, we don't want to set up our processes using GUI. We want to write code, and we want to be able to start the data labeling pipeline on and off whenever we want, just with a few lines of code. So once you have this kind of a setup, your data labeling task consists of these 4 steps. And the first step is choosing the crowd. So usually, depending on your project, you would like to choose people of a specific age, gender, or maybe that they speak a particular language. The next step you need to do is to train the crowd. So it would be writing good instructions, maybe creating some training examples for tests. So in order to avoid something we've seen on our picture with the foxes, we need to basically train our performance. The next step that is required, and this is super specific to crowdsourcing, is using quality control. So basically, there will be always some performers that do not do your tasks correctly. You don't want to get this data to basically spoil your data set. You need to filter those people out, therefore quality control. And at the end, you need to somehow aggregate the results. So usually when you have a crowdsourcing task, you give the same task not to one person, but to several people, for example, 3 people. That way you could get more confident if the label you are getting is actually correct. So this is a crowdsourcing in a nutshell. And I would like to give you some examples from the industry. So the first example comes from the self-driving cars problem. And in self-driving cars, we need to annotate many images with representing different objects. So ideally, we would annotate all pedestrians on the image, or traffic lights, road signs, etc. So how can we do it? So our final goal is to have all these objects annotated with polygons. So the first step is usually to decompose this problem into several ones. So one project should be only directed to one particular object. So we need a separate project for roads, another project from transport, another project for people, etc. And then we ask basically a person to highlight with a polygon a particular object. But what happens if they actually do it incorrectly? Well, again, we don't want to go through all thousands of images and check them manually. What we typically do, we set up another crowdsourcing project where we give the picture with a polygon already, and we ask the person to confirm if this marking is correct. So if we do it for all different objects, we actually have our images marked up. So as a result, we could obtain something like this. On the left-hand side, we have an image without any marking. And on the right-hand side, we can see that road signs are marked, traffic lights are marked, etc. And I wanted to show you a kind of more formal representation of this pipeline in case you would like to copy the idea. I have added here one additional project. This is project 1, in which we actually check if a particular photo contains an object. This comes from an idea that it's probably a waste of time if we send pictures to be marked with traffic lights if there is no traffic light on the picture. So usually it makes sense to do this kind of initial filtering. And then we proceed with the project I have told you before. So we outline an object with a bounding box in project 2, and then we have a project 3 that confirms if the bounding box is correct. Only if our image passes all these 3 steps, it is correctly marked up. So another case that I would like to show you is a model monitoring example using crowdsourcing. So imagine again that you've been working in this self-driving car industry, and you have trained your machine learning model when the world looked like this. But the winter have come unexpectedly, and now your world looks like this. And what happens here may be probably your machine learning model does not work very well yet anymore. But how do you know? You could actually use human in the loop to constantly monitor the quality of your model. And in order to show you this, I would like to first remind you what is a traditional machine learning inference process once you already have a model. So let's say you want to give a prediction for a particular image. You usually send an API request to your model. The model gives us a prediction. This prediction is saved in a database together with the URL of the image. And the prediction is also returned to a user. So this is a traditional machine learning inference that you might be familiar with. and how the human in the loop could be incorporated here. So the first step would be to set up a project in some crowdsourcing platforms such as Toloka. And remember that you've been saving all your model's predictions in a database together with the image on which the inference was made. Now you can sample those predictions and send them to a crowd for a real life data labeling. So that way you would get the labels that can be saved in the database as well. So now your database look like this. You have an image, you have models predictions, and you have crowds predictions that you can treat as a ground truth. That way, you can take models predictions and ground truth and compute some metrics such as F1 score, recall precision, depending on what you are measuring. So this is an idea how this human in the loop can be used to monitor your model. And this was the last example I wanted to show you. So let me give you a short recap of what we have been talking about. So I started talking about these 3 pillars of AI and how data has become a bottleneck to current AI products. We've been talking about how the model-centric approach started to change slowly to a data-centric one. And at the end, we talked about crowdsourcing and how it can help with some of the data-centric problems with machine learning. And if you actually would like to try crowdsourcing yourself, we have a promo code for you. It's Unpack_Toloka. So this will give you some free credit. Try to use it if you want it. If you have any questions, you can ask me in our community. This is a URL code for you to use if you need.
Did you just say Unpack_Toloka? Did I hear correctly?
Yes.
Cool. Okay. Can you please drop in the chat box? Oh, pretty cool. Okay. I would like to see it. Nice. Okay.
Yeah, I will put it in the chat. Nice. And that would be it. Thank you.
Thank you, Magda, for a very powerful introduction. Now I can really say that crowdsourcing is the very serious engineering problem, and it's really a technology. And like, it's really impressive how you guys could scale up data labeling into a very like big platform. And I know like data labeling itself is a huge industry, right? It's actually it's not multi, but it's $1 billion like dollar industry, and it's growing very rapidly, of course, like because it's AI is growing like as industry is growing like a lot, right? So of course, like to build models, you have to rely on data. So like pretty impressive. So this is where will be very cool introduction to another speaker, Leo. And Leo, as I understand, will also talk about crowdsourcing, but on a different angle, using now Web3 and utilizing blockchain. So how now new technology steps in and try to scale up data labeling. So I guess like Leo, you guys have an early stage startup, but in terms of the technology and your approach will be really, really cool to know what you guys have on your plate. Leo, can you hear me?
Thank you, Ada.
Oh, okay.
Yes. Can you hear me? Yeah. I will share my screen. Okay. Can you see my screen now?
Yes, all good.
Oh, cool. Thanks for the introduction, Ada, and thanks for the Unpack AI to organize this event. I'm Leo, and I work as the CTO at IP Protocol Foundation. IP Protocol builds a new solution in Web3 to organize people who do not know with each other to cooperate with each other to label data in a decentralized way. is the chairman of the Web3, and I will introduce how it works and how we can use this solution to provide the human-labeled AI data to AI bots in Web3 and in Web2. As we know, AI is a very huge market, and the data is becoming more and more expensive because our requirements data becomes more and more restricted. We need more high quality AI data to train our AI bots. And here is the cost from the Google, and we can say the cost is very expensive. And even in China, the labeling cost is very expensive now. So how can we reduce the cost of labeling AI data? We have two solutions. And the first one is economy. That means we use the crowdsourcing to label data. We organize the people in the global areas who do not know with each other to label data together, and they use their part-time to label this data, and the cost for their part-time will be not that high, right? And the other one is the sharing economy.
Leo, one more second. Leo, just like I would like to let you know that you are cutting off. Like there is some problem on your side with sound. So yeah, like try to speak a bit slower. I guess it will probably help us, to understand. All right. Okay. Thank you. Yeah.
Okay. Thanks. Okay. The other solution is the sharing economy. That means as a labelers, as a data labelers, if I contribute some data to AI companies, I want to get some earnings from the future income in the AI companies. That means I contribute data, and AI companies use this data to earn some money. If I can share some money from this income, I can reduce the cost of the labeling AI data, right? So in this way, we can say use the crowdsourcing. More and more people contribute the data, and we use the sharing economy to let people reduce the cost of the labeling AI data. And blockchain is a perfect solution to solve these two problems. That's why we have the Epic protocol, this project. In Epic protocol, we want to build an open and a collaborative AI data network. And in this network, everyone can join this network without any permission. And they can earn some money while contributing AI data to this network. And all this AI data can be accessed by AI companies and all AI developers. They can use this AI data to train their AI bots in Web3. And all these things is permissionless. That means everyone, if you want to join this network, you can do that without any permission from the third party. And any developers, if you want to use the data in this network, you can access this data without permission from the third party too. Everyone can join this network and cooperate with each other in a decentralized way. That's what we want to do in the Web3. And in Web3, as for the AI data network, we build two systems. The first one is the labeling system. In this system, people will be organized to label data, and some people in this system will use their part-time to label data, and some guy in this system will use their part-time to check in this is suitable to train the AI bots. There are some guys in this system. They will act as the checker. They will act as the expert. They will review the quality of the AI data and make sure all AI data collected in this system is high quality and can be used by AI developers in our industry. And if the AI data, high quality AI data has been generated in our labeling system, they should be stored in somewhere. If we try to store this AI data in a centralized system, for example, if we store this data in Google Drive or in a Google Cloud, that means all this data can be controlled by Google. So in order to make sure the people who want to access this AI data, this data without permission, we need to make sure all this AI data is stored in a decentralized solution, in a decentralized system. That's why we have another storage system. In this system, we organize many devices to store the AI data in a decentralized way. If you guys have some idle home computers in your house, you can use your home computers to join the storage system to store some AI data to earn some money too. So in this way, we have a lot of the data sources, and all this data, all this raw data will be labeled in our labeling system. Our people, our community members will join this system to label and check the quality of the AI data, and all reviewed high quality AI data will be stored in our storage system. And the AI developers, AI researchers, and AI companies, they can access this AI data in our network. And the people who want to access this AI data, they need to pay some tokens. And the people who contribute data or who contribute storage resources in our labeling system and the storage system will earn some tokens as rewards. That's how it works. How it works in Web3. And here is our architecture. And as for the labeling system, as we say before, we have some guys, they will work as the data labelers. They will try to label some data and they will use some label in this system. And besides for these people, we have another guy. They need to check the quality of the AI data labeled by our data labelers, because all these data labelers is organized in a decentralized way. They do not know with each other. So the quality collected by them may be not that good as a centralized data labeling service. So we need to find some guy to check the quality. Here is how it works. We will have domain experts. They will act as the checkers, and we have the bounty hunters. They act as the data labelers. Experts will design and define what kind of AI data we want to collect, and the bounty hunters will act as the data labelers to help the experts to label the data. The experts, they need to review and verify this AI data. Bounty hunters, they need to check if AI data is good enough to be trained by AI bots. And all the reviewed AI data, all the filtered high quality AI data will be submitted and is how the experts works. They need to define what kind of the data looks like, and they need to publish tasks in our system. And then all the bounty hunters, they will have an app. We call it Knowledge Mainland, and you can download it in App Store and Google Play. We already have 100,000 registered users in this app, and they come from more than 12 countries. They finish many tasks in our system. All these tasks is published by domain experts. If you try to finish a task, that means you help us to label a data. It's a play to earn game for all labelers. You can use your part-time to play and earn in this app. And of course, your rewards will be distributed in tokens because it's Web3, right? So no matter where you are, no matter when you play the game, you can get some rewards as tokens. And the AI data collected by bounty hunters, the experts need to review them and verify which part is good enough to be submitted to our storage system, and it can be accessed by AI bots. So we will have a storage system. If you have a home computer, if your home computers have the idle storage devices, have idle storage resources, you can set up a program in your home computer, and this program will collect with our nodes in the global world, and you can get some high quality verified AI data from other nodes, and then you can store this data in your home computers. And in this way, you can earn some tokens as a reward by contributing storage resources. In this way, all AI data in our network is stored in a decentralized way. That means globally, a low centralized organization can control this AI data. You can trust this AI data is safe and they won't be tampered. As for the AI data, how we use this AI data, we recommend all experts who define the AI data, they need to publish AI bots in our AI bot store to show how can we use this AI data. For example, we have a AI bot. The AI bot ask the data labelers to label which Twitter account is an influencer. Right? We have scratched a lot of the Twitter accounts, and we publish the tasks to ask our data labelers to label which Twitter accounts is a influencer in Web3. Then all these Twitter accounts who has been labeled as the influencer, we will track their tweets and to find what they are talking about, which projects they are talking about, and then we can filter the projects which is very popular in these influencers. We can recommend our users. You need to do some research on this project, because this project maybe can help you earn some money in Web3 because a lot of influencers think it's good, right? So in this way, we build a loop. The experts define what kind of AI data we need to collect, and the data labelers help the experts to label the data, and then the experts use this AI data to build an AI bot, and the AI bot can be used by our users and even by our data labelers. Also, we have built a incentive model, and in this incentive model, maybe some guys think the parameters should be trained, and the rewards given to given to the storage system is too high, we need to reduce the reverse to the storage system. How can we govern this system? We produce a governance tool. We call it DAO, DAO, and the people who have earned tokens by contributing in our system can vote in this DAO, and you can decide which proposal should be passed or which proposal should be rejected. And we also provide a wallet. You can redeem your tokens in this wallet, and you can manage all your storage devices in the wallet. It's very convenient for people who do some contribute in our system. You can manage all your eyesight in our system in this wallet. And we also have some showcase. Here is the showcase. We cooperate with the Singularity Night. They build robots who will act as a nurse in hospitals. They want to some data about the facial emotion. For example, we get a face, a person's face. We want to know if he is happy, sad, angry, or other emotions. In this way, they can train their robots to learn how to be happy in her face and how to be sad in her face, to make the robots more human-like. And we have another showcase is self-driving. We cooperate with 51 Words. They build a simulated city, and in this simulated city, they simulate a lot of the cars. And we ask our data laborers to label the cars on the road, the walking people on the road, and the bicycles on the road, to have the AI, to have to train AI to learn how to detect cars and people in the road. That's what we are doing now, and all the tools are ready. And if you guys want to join and want to have a try, you can go to our official website to find more details. And because we are data labeling, we are a decentralized data labeling system, and we are in the early stage. So in this stage, we can help the AI developers and AI companies to label data for free. But instead, we need to make sure all labeled data should be public. So if you can accept the labeled data can be public, then you can ask us to label this data for you for free. So if you want to get more, you can go to our website, and even you can contact me in the WeChat. Thank you, guys.
Hey Leo, thank you so much. I'm a big fan actually of Web3 and how the world is evolving, and especially like with the idea of decentralization, where kind of like nobody owns the internet, and then like here's like new notion, which is like kind of like radical for AI. Let's actually decentralize AI. So I guess like I would like to open up also like the Q&A part. And as being the host, I probably would like to ask every speaker here, what do you guys think about data privacy in relation to your company, to what you do? Because like here, of course, we can talk about Web 2 versus Web 3. I know like Web 3 guys to always complain about Web 2, that like we as users, we don't own the internet, the big platforms on the internet. But in terms even the data privacy right now, maybe Sara, for you, how what is your concerns? Like how do you deal with data privacy? Because I know like for any big company, for the AI companies, they really care about like data privacy, because like, again, they have the users and they take the data from users, and they want to make sure, for example, like, it's data is secure, there is no leak, right? And it's also ethical. Ethical AI is a big concern here. So maybe like you, as all the speakers, one by one, you can talk about data privacy, how it's related, to what you do, and then maybe like also Leo, like talk about like, this new notion of like decentralizing data. Sara, let's start with you.
So sure. So at Meridian, our policy for data security is that we have to implement across the board the same policy, assuming that the country that we're working with is going to be the most restrictive possible. So a lot of our clients are based in Europe. They have very, very restrictive, very, very careful data privacy regulations. So we just have to treat all of our data as if it's going to the most strict country in Europe. So regardless of whether the project is for one client or for another, in the end, I mean, we've seen so many changes in the way that different countries are handling these regulations. We've seen lots of changes in China as well. We just have to assume that unless we want to pay for it later, we just have to be really careful right now with all the ways that we handle our data.
Cool, thanks, Sara. Magda?
Hi, so I have pasted an answer, a bit of an answer in the chat so you can read, but let me explain here. So we have different data protection problems. So for example, for the performers, the people who are doing our tasks, first of all, we try to identify them in some way. So we need some proof of identification from them. And then their data is protected in a way that no one from the requester side can see their personal information. So they can only see the user ID of a performer and some basic info, like maybe what gender they are or like what languages do they speak. And then from the requester side, usually the problem that people ask us a lot is how do we store the data? So actually in Toloka, we don't store the data. When you request data labeling, you actually use your own storage. It could be anything like S3 or some kind of S3 storage. So we do not host your data itself. You just send us links to it. So I think those are the basic cases. But if you would like to learn more, there are some specific cases that are actually outlined in the link I have sent you in the chat. This is a link to our data security page.
Thank you, Magda, for a comprehensive answer. Yes, definitely. You guys should have like the entire protocol on how to deal, like data privacy and security here. Leo, and then getting back to you. So you guys are going to share the data in decentralized manner across all the stakeholders in your DAO. What is the concern? Like, how do you guys solve the concerns about data? I understand the blockchain is the part of the answer. Maybe like you can unpack that part, or maybe like, there is a complex approach to this problem on your side. Leo, can you hear us? Is it the problem on my side, or just to make sure? Or Leo, we
no, I can't hear him either. I see the green border, which looks like he's talking.
Yeah, like Leo's trying to talk. Yeah, Leo, maybe there is problem with your sound system. Maybe you turn off the mic. Okay, yeah, we can't hear Leo. I think, Leo, if you'll fix your audio, then you can answer this question. But we also have some other questions. So let me just scroll a bit up. So the questions from Toloka, they were already answered in the chat, thanks to the Toloka team. And yeah, like Albert is asking, are there tools available for us to deploy distributed data labeling tool? Or do we need to develop an app or build our website to do this? Right. Magda, if you can take maybe this question, and if Sara, if you want to also jump in. Distributed data labeling tool. I guess you guys already have that, but maybe you guys have your understanding of this question. Or Albert, you can unpack your question. Yeah, Magda, if you can jump in for this one.
Yeah, okay, I'll go. So I think at least how crowdsourcing works is by definition distributed data labeling tool. So basically the data you send will be distributed to several people in different locations, in different countries, etc. And then you will gather the results. I don't know if this is the right answer to this question. If not, let me know.
Yeah, I think like then he says about Label Studio. Maybe it's open source tool you're talking about, Albert.
Yes, can you hear me?
Okay. Yes.
Yeah, I am using Label Studio and Label IMG Master. Now these tools are based on the Anaconda, and already we have difficulty installing these programs. Now I would like to have a lot of people over to try to help me label the data. But then it would be very hard to ask these people, they are laymen, they are not tech people, to download and install these programs. So is there a ready made tool out there which we can use so that anybody can just open a web page and start labeling?
Okay, so this is exactly what Toloka does. There are already thousands or millions of people that already have an app. So this is exactly our crowd. So imagine that I don't know what industry you work in, but let's say you have some classification task. You just post this task on the website, and our platform will distribute it to people that are in different places. So basically the crowd is ready to start labeling whenever you want. They don't need to download any additional programs or anything like this.
And I can chime in with one recommendation. If you're looking for a tool that's something that you could use more in-house that you have more control over, we've worked with Basic AI before. They have a pretty robust system that you can customize, and we found that to be very helpful.
Interesting.
Thank you.
I guess this is where, if we talk about startups and the individuals who are working on their own AI projects, they might go for the open source tools like Basic AI, as Sara mentioned, or Label Studio. If you are a big company and you need, again, like, you have like time pressure, but again, like you have like big project, you have the budget there. This is where like, you can utilize, for example, big platform. Again, like where you stand at, depending like, how big is your budget, I guess. You go for different companies. Magda, I also have the, like, what is you take the percentage, right? As a platform, how do you price your service? And then maybe like get back to Sara, how do you price and what is the process? So maybe like get to Magda and then get back to Sara about like, what is the process? You have the in-house team, Sara, I guess, within your company who do the complete data labeling service. But Magda, you guys like, distribute across all the like Tolokas, performers. And do you take the cut as the platform? What's that?
Yeah, we do take the cut. It's 30%. And in terms of pricing, our requesters actually choose their own pricing. So you might imagine that you want to pay 10 cents for labeling a picture. You basically, as a requester, decide the price, and we take 30%.
Sounds good. Cool. Okay, Sara?
Yeah, Meridian, generally, each project that we handle is so customized that we generally prepare a customized quote that's usually based on the amount of time that it will take and the kind of persona of linguists that they're looking for. So in some cases, they're looking for highly trained, PhD in phonetics, Indonesian speakers. And so we need to put together a pretty elite team, and we need to charge for that. Sometimes we are able to use a very different kind of persona of linguist that maybe doesn't even have any specified specified training, but maybe they're just a native speaker of Tongan, and we can wrestle up 50 native speakers of Tongan, and we can provide a much more budget friendly budget for that. So yeah, for us, it still is very customized.
Makes sense. Yeah. Cool. Mark, you raised the hand. If you can speak, please.
Yeah, I have a question for Leo, but I don't know if he's available right now. So
Leo, let's check with you. Let's check first with Leo. Can you talk, Leo?
Can you hear me now?
Okay, great. So Leo, we'll get back to the previous question you didn't answer about the data quality, but let's get back to Mark, and then Mark verbalize the question, then Leo answer this one, then get back to the data quality concerns. Web3. Okay, cool. Mark?
So should I ask first, or are we
Go
going to
ahead.
go back?
Go ahead. Yes, go ahead. Yeah.
Sure. Leo, my question is about your NFTs. I think algorithm that you were talking about, that you were going to be sharing about NFT influencers and all that. Do you already have that set up, and is it already working, or is this something that you plan on launching in a couple of months?
Actually, we already have a platform to do this, and as for the NFT influencers, we have collect some AI data from our data labels, and we publish the AI bots in our Discord. And if you can join our Discord, you can find we have bot channels, and the bots will recommend some project for you, and all these projects are filtered from the NFT influencers we have tracked in the Twitter accounts.
Okay, I see. So I should just follow your Discord and your Twitter then, right?
Yeah.
I think guys, you through the slang here, NFT, it's very hard to surprise people who heard NFT first time, because we all probably heard about NFT, but maybe since you talk about NFT, what is NFT and what the NFT plays in your company? So it's AI bots. NFT will be the way to attract the performers, the bounty hunters, or what is the role of NFT in your platform, in your DAO?
Yeah. NFT act as a community part in our community. That means we have published a lot of AI bots, and all these AI bots is developed by AI developers and by our community members. They have some cost to develop AI bots like this. So some of the AI bots will be published for free, and everyone in our community can use them. And some of the AI bots will be published in a subscribe payments or other payment methods. That means in this way, some AI bots leads you pay something to access these AI bots, right? And NFT acts as the pass in our community. If you hold an NFT, and you can access this professional AI bots in our community. Yeah.
And AI bot, as understood from your talk, it's a showcase of what you can do with data, right? So, for example, AI bots in speech recognition that can, for example, use the data that you have in your distributed network, and then show how this data can be used to build speech recognition AI bots. Is this the part of that?
Yeah. The AI bots in our community can be understood as a Telegram bot, a Discord bot. They can help you to finish some predefined tasks. And but all these bots has been integrated by AI, and this AI is trained with our data in Epic Protocol network.
Great. And getting back to the first question about data privacy, do you expect that big companies, Fortune 500 companies, will jump in and utilize your service because they're super concerned about data privacy? Yeah. How do you solve their concerns? Yeah.
Yes, it is a very good question. as for us, the big companies won't contribute data for us, right? It's truth. But the interesting thing is the big companies want to access the data in our network. So they don't want to contribute, but they want to access. So as for the data privacy, we think we pay a lot of attention to this. So on our side, we only submit the knowledge data into our network. For example, we have a lot of the yearly information about people, but we only submit which performance will be caused by which yearlies. This knowledge information, all this knowledge information is contracted from the raw data. The data privacy will appear in the raw data, but the data privacy is hidden in the knowledge data. So we ask our data labelers to label the knowledge data from the raw data, and then we will submit the knowledge data into our network. Yeah, in this way, we want to get rid of the data privacy.
Yeah, still need lots of things to unpack with your project, which is pretty cool. Let me quickly check if there are other questions. I think the questions are answered. Maybe then we'll wrap up the session. I think I would like to have one more round with each speaker. Maybe like Sara, maybe you can again introduce what you talked. Maybe like have some any other ideas that raised during this discussion. Maybe like so we have 7 minutes before the end, 2-3 minutes for each of the speakers, and then we'll wrap up the session.
Sure. I could do a quick summary basically about what I talked about in the beginning in case anyone missed it. I basically highlighted the different kinds of roles that linguists and language specialists have in preparing data for machine learning. So if you're preparing for a natural language processing project that involves, say, speech to text, or that involves sentiment analysis, you need to work with linguists that are trained in the specific field, whether it is to recognize the sentiment and to annotate the data in a useful way, or whether it's phonologists that understand how to transcribe phonetically and to mark sounds in a specific way. So these are all different roles that linguists can play. And it's very important to understand the different roles so that you can make sure that you're training your data correctly. And I really liked the way that Magda was presenting the conundrum of whether you judge the quality of the output based on how good the output is, or whether you judge the quality of your data based on the quality of your output and then go back and change your data. My company is also trying to get you to the good data faster by making sure that you're training the data the right way in the first place. So I hope that's helpful.
Great, thank you, Sara. Magda, then.
Sarah. Yeah, I go. So I have started my talk with talking about 3 AI pillars, and those, to remind you, were algorithms, hardware, and data. The first two have been vastly explored recently, and data was kind of neglected. We can see a trend that is changing now, and people in AI industry start to focus on this data part. And this is where Toloka jumps in. It can be used to gather high quality data labels, and it can be used also to monitor your machine learning models, as have been shown in the example. And if you want to try Toloka, I gave you a promo code. It was, you can see it here in the chat as well, so you can.
I can copy it again. Yeah.
Yeah, thank you, Either. So if you want to try, I think there is $30 for you there. So I think that would be it from me.
So just to make sure, $30 are for the requesters, for the, again, like the companies that need the data set to
exactly.
Build. Okay, just to make sure. Okay, for the audience. Thank you, Magda. And Leo, okay. Let's wrap up with you the session.
Great. We think the AI data is the fundamental to AI in the future, and we'll focus on to will focus on curating high quality AI data in a very low cost with the help of the blockchain. So we are trying to make all these tools more convenient for our users and make more and more people can join us to curate high quality AI data and publish all this AI data to make them accessible to everyone in the world and to make our AI better, right? So if you guys want to try the AI bots, you can join our community. And if you guys want to label some AI data for free, you can contact me. Yeah, we can have a try in Web3.
Maybe you can also drop the link to your Discord channel since you mentioned that.
Yeah.
You send the link to your website. Also, Toloka send the Slack channel. I like, like Slack and Discord. I like this Web 2 versus Web 3. So exciting. Cool. Thank you, guys. Everyone, thank you again for joining. Thank you, Sara, Magda, Leo, for being today, for giving your time. I know you guys are super busy. And for everyone, well, I hope it was a very useful session. I hope you guys understood how it is important for in AI to prepare properly the data and what are the solutions are available. Again, like depending on your needs, right? So if you're individual, if you're a small startup, maybe you can go, for example, with Leo's startup. If you don't have any privacy, if you need like a very specialized data set for NLP problem, you'll definitely go to Sara. If you're a big company, if you have the budget, and if you want to, for example, receive quality data set in a very short time, go to Toloka. That's my understanding. You guys might have your understanding. But again, thank you guys again for joining, and see you next time. Okay, bye-bye.
Thank you.
Thank you, guys.
Thanks, everyone.